Okay, so let me show you something about this Phet simulation here with the interference. So if you pick the interference part here, I've already set it up. Um, and let's make it full screen here. But I've already set it up to the situation that I like. And here's what I'm thinking about. So I have two water spouts here that make sort of these water droplets. If I press play here, you'll see it. So I can either turn this one on, or like turn them both off. Right. And what I've set up here is I've set up two, um, I guess you can call them probes that are measuring the water level at these two specific locations. So in some sense, you can think of that as measuring the disturbance of the wave at a specific location, and then you're plotting that as a function of time. So as time passes by, what is the water level at these two probes? And then you'll see here in this plot, you'll see two plots. One of them is light gray corresponding to this one, and the other one is dark gray corresponding to the other one, to the dark gray one. I put them in these particular locations for a reason, and I'm going to show you why I've done that. Right now, it's actually plotting, but you don't see it changing because the water is flat. It's it's not moving at all. There is no disturbance at all. So both of them are showing flat. In fact, it's playing. You can see that the pause button, the play is on. And if I turn this tap on, to drip water drops with a specific frequency, which I can play with here. So I can make it a little faster, a little slower, right? Or I can change the amplitude. So how much does the disturbance happen? You can't really see it right now, but I've placed these at equidistant, the same distance away from where the drop hits the water here. So you see that I'm getting exactly the same amplitude with the same phase. So they both are measuring the same level at the same time, right? And you can see that that could be different if I turn the other one on. So I've turned this one off, and now I've turned the other one on. And you can see that this one now gets a little bit higher. The dark gray gets higher. And now this is what they're called out of phase. These two signals are out of phase, the water level. So this one gets high, and then this one gets high. So it gets high, and so on. So that's changing the story here. These buttons here can tell you, you can pause the simulation just if you want to check things out. You can go ahead one frame at a time, or you can just make it go slow so you can observe the phenomena as it's going on. Now I've set them up in particular positions that I like, because now if I turn both of them on, you'll see what's going on. Now keep an eye on this graph. First of all, you know what, let's just turn this one on again on its own. So I just have this one on, and then what you'll see is that they're back in phase. And then now I'm going to introduce the next one, but I want you to notice what's happening. So I'll just make it a little bit slower to see what's going to happen on the other one. You can see that the two sources are in phase. The two drops are hitting the water at exactly the same time. Notice what is starting to happen here. See that the light gray now is measuring a disturbance that is bigger than what it was measuring before. That's happening at this location here. It's measuring a wave that is the sum of the two waves, but at this particular position, these two waves are actually adding up to give me a higher amplitude, while at the dark gray location, the waves from the two sources are subtracting from each other. So you can call that destructive interference. You can see that it's not completely destructive. There's still a little bit here, but if I got it exactly flat, that would be completely destructive interference. But right now I have somewhat destructive interference on the dark gray one and constructive interference on the light gray one. And you can compare it again to just one source by turning the other source off, and you can see how it's going to return to the two of them being in phase again once this wave passes by. Look at that. They come back in phase, same amplitude and the same phase. Now you can play with this yourself, and you can start to, you can get the measuring tape, and you can start measuring from the location where it drops, and you measure from here to there, and you figure out what the distance is. You measure from here to there. Oops, I didn't mean to move this one. I meant to move this one here. So I can measure from here where the center where it drops to this location. I can find out exactly what the distance is. So obviously in this case, I've set it up to be equidistant. So they're both 5.7 centimeters away from where it's dropping. Right? So that's why they're getting the same amplitude at the same time, because these are these circular waves that are proceeding from here. Right? But then of course there are different distances from where the other one drops. And then because you have the time measurement here that tells you this is 1 second, so you can in fact figure out exactly what the period is of this wave. And you can figure out what the wavelength is by pausing here and measuring between two successive crests. You can figure out the wavelength, and from that you can figure out what the speed of the wave is if you wanted to. So this is an interesting simulation here that you can use to play and figure out what the conditions are for the interference, and verify the conditions about the difference in path length. And when it's half lambda, 1.5 lambda, and so on, you get something completely destructive interference. But when it's 1 lambda, 2 lambda, 3 lambda, 4 lambda, you get constructive interference. So give it a try, play with it, change things. You could also turn it, instead of water waves, you can turn it into sound waves, and you can play exactly the same game again by turning the sound waves on. And you'll see the kind of interference that happens here, but instead of measuring the disturbance in the water wave, now we are measuring the pressure. Right? And I can change the amplitude, so that changes the height of the wave here. I can change the frequency, make it slower, right? Make it faster. And then of course I can change the location of these things and figure out where the constructive interference happens and where the destructive interference happens. You can look at these waves here. So go ahead and give it a try and play with it, and see if you can figure out these conditions and verify them for yourself.